Okay,
Yeah.
now
Okay.
you can either create your designs in Rhino, or if you already have a file that you want to work with, and I have a file that you had emailed us, so we'll go ahead and take a look at the file here. So you see there's a file, the DWG that you had sent us. I'm just going to go ahead and drag it into Rhino here. I can choose whether I want to open or insert, import it. I'll just pick open, and this is going to open the file, and it'll ask you with these import options in Rhino whether you want to bring the model units in millimeters or is it supposed to be in inches. Let me know, and I'll go ahead and load the file for you.
I believe it's in inches because
Okay.
it's from Gibson.
All right, let's go ahead and set it to inches here. Then we'll select OK, and you'll notice that it loaded the file you're drawing right here. Now, if you weren't sure about the dimensions, you can actually try to maybe pick the center line that you have, and you can say analyze length. So this measures about a little under 18 inches. So that sounds, to be right, to be in inch units, correct?
All right. Yep.
Okay. So it shows like you have a 2D layout of like a guitar body. Is that what you're trying to cut?
Exactly.
Okay. All right. So we want to go ahead and make sure that the units is correct, and then once you set up the units, you want to make sure the part is in the desired orientation for machining. So if the length of the piece, which is about 17 inches, this is oriented parallel to your y-axis. If that's how the way you want it to be oriented, you don't have to rotate the part or do anything else. Or if you wanted to lay it on the x-axis, then you have controls to rotate it in here as well. Okay?
Okay. Yeah, no, it's fine the way it was.
Okay, so I'm not going to make any changes. Just leave it the way it is. So most of our users who use our product for building guitars, they kind of want to put the 0 right on the center line right here, somewhere the 0, 0, 0. But the choice is yours, however you want to zero it. We'll talk about that in a few minutes. Okay?
Okay.
Sure. So the first step we want to do in the machining is you define the machining process. So you pick the machine type, you set it to 3-axis. For 2 and 3-axis machining, you pick 3-axis. And 2 and 3-axis machining is available right from all of our configurations, starting with Express. So Express standard does include 2 and 3-axis machining.
What was that?
So we have 5 different levels or 5 different configurations in RhinoCam, and all of our configurations offer 2 and 3-axis machining. The standard configuration offers more of the 2.5 and 3D machining over the Express configuration of the software. So for a part like this, I would recommend the standard configuration. It gives you more control and more choices for programming.
Okay.
Okay. All right. So we got the machine tool defined. The next step is to select the post processor. So this would be the machine tool that you'd like to, output the code to. Do you happen to know what type of machine tool you're going to be working with?
No, we're brand new to it. We don't know. We need guidance.
Okay. Have you made a decision on what CNC you're purchasing?
We're looking at a couple different machines. Now, what this body would be wood, a mahogany, so I assume it would be some type of cutting bit, some type of router bit. Is that what you're asking?
No, what I meant is what type of router are you planning on getting? Do you know, do you have a specific brand name of CNC that you're getting?
We're looking at a bunch of different things, but we don't have anything right now.
Okay. Well, here's what I can say. As long as the machine reads G-code, we have post processors for over 300 different posts in the library here, which covers a wide range of machine tools out there. So depending on whatever machine tool you're getting, as long as it reads G-code, we'll be able to support it. The posts for these machines.
G-code or D-code? G-code.
G as in George.
Okay, so those are what you're showing us right now are the different machines that you support right out of the box.
Yeah. They're either listed by the name of the machine or could be a name of the control. For example, here it says FANUC. FANUC is a controller, or it could be a machine tool, like for example Haas. It could be a name of the brand name of a machine. We work with several different types of machine tools in here, like Mach is a controller. So for example, there are several different machine vendors. They use Mach for their control. So the posts are either listed by the name of the machine or the controller. Now, for our purpose of today's demonstration, we'll just pick one of these in the list, okay? So this is something you would select once you define.
Hang on one second. There was one that you had emailed me that you were thinking about. What was that?
Well, there's one at Rockler that I wanted you to look at. That's what I'm trying to find right now. There's a couple different machines we're looking at. You're talking about what machine we're going to buy. Is that correct?
So that would depend on, the post-processor selection will help you determine based on what machine you're getting. So if you happen to know that, that's fine. But we can also talk about that later as well. It's not going to affect how we're going to be programming the part for the demonstration. It's just going to be affecting what the output would look like, because it's going to be slightly different for each machine.
Yeah. Do you support? We're looking at a small one to begin with, a real small one just to play around with, like it's called a Shark. Do you support that?
Yeah, I believe we have a post for like a CNC Shark. It could be in the list right here. CNC Shark right here.
Yep.
Yeah.
Okay, so we can select that, and then we can put the extension as NC. We can select it. So the next step we would do is we go ahead and create the material, the stock material, the blank that you need for machining this part. So you can select box stock, and the system will automatically look at all of your extent of the drawing that you have, and it gives you the minimum stock you need to be able to cut this part. You can enter in your length, width, and the height that you like to go with. Here you can say the length, which is basically on the x-axis. I can say the minimum size you need is 12.97. You can say you have a 14-inch piece of material, or 13.5, depending on whatever the dimensions you have available on hand, right? So you put in the dimension in here. I could say 13.5, for example, and then this could be a little over 18 inches or 18.5. And then the thickness of the material, if it's going to be 1.5 inches, 2 inches, 1 3/4, you put in the material thickness.
No, make it 3 inches.
3 inches, okay, we'll put in 3. So we define the stock, and then you can click on show stock. That displays the stock right up on your screen. Okay, so there's your piece of blank. So once you have the stock created, go ahead.
Now the fact that I sent you a 2D drawing, is that a problem?
Not at all. We can work with 2D drawings as well as 3D models. So if you're going to be primarily doing like some cutting, like pockets, profiles, and you have information on how deep you want to cut them, we could just work it off a 2D drawing.
Right. Okay, so we can kind of do it on the fly then.
Absolutely.
Perfect.
All right.
Okay. Good.
If you want to build a 3D, you can build a 3D in Rhino by picking all of these curves, and you can turn them into 3D. That's something you can do. But for programming this, we can still work with a 2D drawing. So the next step we want to do is aligning. So I can say align the stock to the part. So I'm going to align it. So I'm going to have it centered in X and Y. So there's material being left on all the sides, as you see it right here. Okay. And then for the Z, I'm going to put it to the top. So the top of the stock is flushed with the top of your drawing. Okay.
Yep.
Okay.
And then we'll select OK to accept it. In the next step, you'd want to specify where would you like to do the XYZ0 touch off. So when you place this workpiece on your CNC table, you typically want to bring the tool down in the Z and then X and Y to set the 0. It could be sitting to one of these corners of the block, which could be easier, or you can put it in the center in X and Y and then the top face, or you could be putting it right on the center line, depending on what you feel comfortable and what would be a good practice to do it.
Yeah. My comfort zone on that is in the corner.
Yeah.
In the corner. Okay, so that's what most of our users do as well. So we would do align set world coordinates. We'll put set to start.
This point, this is not. This is just like a reference. Is that correct?
That's a tool reference.
That's the.
Excuse me, sir?
It could be called your program point or work origin. So all of your XYZ coordinates is interpreted or represented based off this XYZ0 location.
Right. That's what I was saying. It's like a reference to start from.
That is correct. So right now, I'm setting it to the XYZ origin. You can see it automatically shifted the drawing to the stock to the origin in here, and it's set to the top of the material. So now when you go ahead and save your file in Rhino, it'll automatically save all of the information that you put in, like the machine, the post, the stock, all of this is saved to the file. Okay.
Right.
So the next step is we want to start programming our toolpath. So before that, we can create some tools. RhinoCam offers a wide range of tool types, starting with ball mills, flat mills, corner radius, tools for engraving, chamfer bits, taper, thread mill, face mill. You have dovetail cutters, fillet mill tools, lollipop cutters. You can also create custom tool shapes like form tools. And then you have the standard tools for drilling, drill, center drill, reamer, tap, bore, reverse bore. All of these tool types are available, and you can define the tools, set your feet and speeds. You also have a built-in feet and speeds calculator in here based on the material type. So you can build your list of materials in here. So in this list, we have a type of material for wood. And if you want to build a list for different types of wood, like hard, soft wood, you can basically add to this list. And based on the surface, the property of the material, RhinoCam can help you determine feet and speeds. So you can either create these tools, or if you already have a library of tools that you had created a while ago, I can go ahead and find a tool library in here. So for example, I can look for a tool library in here, and I can go ahead and load the tools. So I can, let me see here. Let me go ahead and try to load a tool. So I'm going to load this tool library. It's called Tools, Inch, and the Drill Tools. So you'll see that there are about 180 tools in this library, and they're all loaded right there. Okay?
Yeah. Okay. Yep.
So the next time you open up a drawing or open up Rhino, it'll automatically preload the last loaded tool library for you.
Okay, now, you were talking about before, you're saying that RhinoCam can help us determine which bit we want to use based on the material we're cutting?
RhinoCam will help you establish the feet and speeds or determine the feet and speeds based on the material you're cutting. So for example, if you're cutting wood and the tool is high-speed steel, it gives you a recommendation for your cut feed rate and the spindle RPM.
Okay, cool.
You can use this as a reference to start with, okay?
Yeah.
Okay, so looking at this part, it looks like you would want to cut this pocket in here, right? The one that you have here, and then you want to cut this. This would be like a secondary pocket operation that you'd like to do.
Yep, that first one, the one that you pointed to right now, that first one would go down 1 inch.
Mm-hmm.
And the top one, that's going to go down 1.5 inches.
Okay. There's a few things we can do to simplify or make the process easier. Is I can select these two and then join them together, because these are basically, you can see there are 8 curves, individual curves. You can basically chain them or join them. Just makes your selections easier. And I can do the same thing for these ones in here as well. So I can drag a window to select all of those and then join them just to make it easier. So now we'll go ahead and add a pocket operation. So we'll do a pocket. We'll pick the select curve edge region. So we'll pick this. That's your boundary you want to cut, right? The pocket boundary. And then you go make a selection for your tool. Whether you want to use a 1/2 inch. So it depends on what the radius of this geometry is. You can do analyze diameter, and you can see what the diameter is over here is to figure out what size cutter you would need for it, right?
Mm-hmm.
So you can determine what size cutter you want to use. I'll just go with a 1/2 inch in here. Set your feet speeds. You can put in the clearance height. So that would be the height for all your transfer motions. It's set to a 1/4 inch above the material. And then you go into your cutting parameters. You choose your cut pattern, your cut direction, your step overs. In the cut levels, this is where you specify how deep you want to cut. And you said you want to go 1 inch deep. And you can go in multiple steps. So rather than taking out all in one cut, I could say I want to go in steps of a 1/4 inch each. And then I can put in all the parameters for the entry and exit, and then pick generate. So in this process, it's going to create your pocket operation. So from a 2D drawing, you're able to use the 2D as the boundary for the pocket, but then specify the depth and how deep you want to cut. So now let's go ahead and run a simulation in here, and I can simulate and I can apply different colors for each operation in the simulation. That's a very nice feature you have, starting with our standard configuration. And you can select the operation in here. So you've got your stock, you pick the operation, you hit the play button. That shows your material removal, cut material simulation.
Very cool.
Okay, now we would like to repeat the same process for these 2 pockets. So I can do a copy and a paste. And then I can double click to edit this. Then I can just drop the larger boundary, pocket boundary, and I can pick these two. And now I can specify how deep I would like to cut this. So we know that the first 1 inch is already been cleared out, right?
Right.
Material. However, you still need to clear out the material on the side walls because this is going past this in here. Am I correct?
Right.
So there's a couple of things we could have done. In the first step, we could have actually opened this out here, right? Cut it.
Open this out.
So we can actually.
I got a question.
Boundary. Sure, go ahead, sir.
How deep are those holes? Are they 1 inch deep
1
as
inch,
well?
yeah.
So that so it's you're just going to have. I see. You're just going to route into one route.
Yeah.
And the reason why it's a full drawing like that is
depending on what pickup you put in, you may or may not have those.
Oh, okay. I got you. All right, I got you. Okay, go ahead. I'm sorry.
There's one thing we could have done here is rather, this one is going to go deeper than 1 inch, if I'm correct, all right?
No, they're all going to be at 1 inch.
Okay, they're all going to be just 1 inch deep? Okay, all right. So what we can do is we can.
He just asked that question. The reason you have the two things on the side, depending on what pickup you're going to put in that spot, whether or not you will need that extra cutout.
Okay, all right, okay.
In some circumstances, you wouldn't need that.
Okay, so what we can do is the same process for these two. You can pick a smaller tool, maybe go with a 1/4 inch, and then generate it. So this will take care of cutting this pocket out, and then I can choose a different color on this for the simulation. There's your pocket operation for it.
Right, that's perfect because it's different radius.
Yeah, right.
Right, okay.
And then you want to drill these holes, you can do a drill operation for it. Or if you don't have a cutter that matches the diameter of the hole, we can do a hole pocket or a hole profiling in here as well.
Let's say that again. I'm not sure what you're saying.
If you do not have a tool that matches the diameter of this hole, then you could program it as a pocket or a profile operation if the tool is smaller than the diameter of the hole. If you have a tool that matches the diameter of this hole, then you can do a drill operation. So there's different ways how we can program it.
Okay, so the radius, say it was we used 1/4 inch, but say we only had an 1/8 inch cutter bit. So we could cut that with the 1/8 inch, but it would be a different operation because it's not the right radius.
Rather than doing a drill, we'll do a pocket.
Right, gotcha. Okay.
Yeah, so if you have a tool that matches the diameter of the hole, then you can do a drill operation. So basically it just goes down in one pass, or you can do like a peck and a retract to do it in multiple passes. Gotcha. So we'll talk about a drilling here. So let's go ahead and see what this diameter will be. So we can do analyze diameter. Okay, for some reason it's not giving me the correct diameter because it doesn't seem to be a NURBS curve, or it probably is not an arc or a circle. So if we do what is it, you can see it tells you this is just a valid closed curve. It's not a circle. It's not defined as a circle. So what we can do here is we can still do a drill operation, or we can try to draw a circle on top of this using a command called 3-point circle, and we can try to figure out what the diameter is. I can draw a circle.
Yeah.
I can go near this point here. I can do analyze diameter. So that's 0.051 radius, so 0.102. So if you don't have a tool that fits this, diameter, 0.102, then we can just do a profile operation or a pocket. So let's say we have a 0.102 tool, we'll do a drilling operation, hole machining drilling, and then you just go pick the holes that you want to drill. And then you go find a tool for it. So we need to find a 0.102 cutter. So I have a library of tools in here, as you can see right there. So 0.1015, that would be the closest one, number 38 drill, for example. and then you specify how deep you want to go on the drilling. Would that also be a 1 inch deep hole?
Yes. Yes.
Okay, so we'll put in 1 inch, and you can actually peck rather than just going to the depth in one cut. You can peck, and you can say each peck you only want to go like maybe 200 thousandths, and then generate it. So that'll get you a deep drill operation. And in the simulation, you'll see that the cutter pecks and retracts. Okay.
Okay.
So we got through the drilling. The next step is to program some of these pockets in here, right? So the workflow would be very similar. So you want to cut this out first, is that correct?
That
or would
is,
this be from the other side?
God, I wish I could point it out to you. Okay, you see the circles with the lines going through them?
Mm-hmm.
Right, those circles, you go to that next part out.
Okay.
That is what's going to be cut out. That's the actual cutout. The line after that, going out, that's actually the cover.
Okay. So we want to cut this pocket to a certain depth?
Yep, that's what we'd be cutting.
Yeah, that's the only cut we're going to end up doing. The other stuff is all ancillary equipment.
And that's going to be 2 inches.
Okay, so we'll go ahead and pocket this out. So I'm going to make a copy of the pocket operation. I can paste it down here. And then I'll do is basically select these. So rather than having to select each of them individually, I can use a command called select chain, and it'll automatically chain all the tangent geometries that are tangent. So we have these selected in here, and you said you want to cut it to 2 inch deep. So we'll change the depth to 2 inches, and you can go in multiple steps and generate. So your pocket operation. To minimize the number of tool changes, I can move this to the top of the list here. So you got the first pocket, and then we can do the next pocket in here before we swap the tools out. So we're going down 2 inches deep on this one. This one is only going 1 inch deep. So you can see that you're able to select the geometries to program it.
Yep, very good.
Okay. So this is how you typically go program it here. And then you can do the same thing for the pocket in here as well, depending on how deep you want to cut it. At the same depth, you can add it to the same operation here. If these two pockets need to be cut to the same depth, you can program it all in one operation.
Okay. Huh?
All right.
Yeah,
now,
you want to cut 2 of those holes. You could have cut both those holes at the same time, right?
Absolutely. I could even add all of these holes to the same operation. If they're all cutting to the same depth, you can just program it in one operation.
Right. So that second pickup is the same thing, right?
No, second pickup's 1.5 inches.
So it's not
down.
Okay.
It's down lower, so it's 1.5 inches. Gotcha. All right.
All right.
So it's not the same operation.
Right. So if it's not the same depth, then you program them in separate operations. But the nice thing is you can actually copy and paste the operations. So you don't have to, all you got to change is just the dimensions for it. That's the only thing you change. Right. So I'm going to take this operation in here. We created this one. We'll do a copy, right click copy, right click paste. And then we're going to select this, double click to edit, drop the first pocket, go back and select this one right here. Then all we do is change the depth from 1 inch to 1.5 inches, generate it. Now we can do the same thing for these two, make a copy, paste, then pick these two shapes out, and then change the depth to 1.5 inches, and then generate it. So now if I right click and say simulate until, it's going to simulate each of those operations for us. And you can see the depths are different if you look at it from a side view, or you can see that there are different depths. There's 3 different depths. Okay.
Yeah.
All right. So the next step you would want to do is cut this open pocket out, right, in the front.
Is that on the front or on the back?
No, that's the front.
Okay.
He's right. That's for the net.
Do I pick these curves in here, or do I pick the inner one for the front?
Okay, the tenon, the outside, yes, what the ones you have yellow, that's what you want to cut. The inner line would be actually the tenon of the neck that you're going to
Okay.
place in there later on.
Okay. And does this go all the way through, extend all the way out?
Yes, it does.
Okay. So what we would probably want to do is pick these in here, and we want to split these over here. This particular one, I would rather split it. Okay. Because we want to go all the way out straight in here, right?
Right.
We'll pick this one. So you have two curves in here. So we'll actually have to, pick these outlines in here, right? So I'm going to select these and then join them together just to make it easier. And we can do what's called an open pocket machining using a method called, we have a method called profile, facing, which we can use for machining open pockets. And these ones, I'm just going to temporarily hide them in here. So just to make it easier, or I can even lock them so I don't have to select them from being machined. So you see we have these two lines in here, right here, right? And I need to connect these to these lines. The lines are missing in here as you see it. Okay?
Okay.
So this one I can explode it. You can see these lines, they don't, are not right on top of one another. You see the difference right there?
Right.
Yeah. So what I can do is take this line and I can extend this. I can draw a line in here. I can go from the end point right here. I can go from the end of this line, and I can go all the way through to this point right here. So now I got these three lines. I can join them together. I can do the same on the other side. Draw a line. Or I could have mirrored it as well in Rhino. So there's different ways how we can do it. Then extend the line right to this point. Now
as far as manipulating the join, we have a lot of experience using Vectorworks, so we know how to manipulate the pieces.
Okay, so you can do the same here. So now that we have this front section selected in here, we could do we want to mill this pocket to a certain depth in here, right?
Right, but now I have a question for you.
Go ahead.
It's going to be going from, say, all the way to the left. How you're looking at it now, it's oriented to the left where that curve is.
Mm-hmm.
You want to start going down 1 inch, going all the way to the right. It's going to be an angle.
Okay.
So it's going from 1 inch down to, say, 1.5 inches.
Okay, so which means you need to model a surface with a draft and program it as a 3-axis operation. That's where you get into 3-axis machining. So you actually need to model that and do a 3-axis machining.
Okay.
So you can have a floor with an angle. So what I would do here is, put a surface by selecting all of these in here. So to cap that, and then we would be doing like a 3-axis operation. So first step is to basically put a surface by picking all of these. So I'm going to join these together first. So that this basically is the outline of the guitar body, right?
Correct.
Okay, so I'm going to join these, and I'll insert a surface. I can put it in a new layer if I'd like to. I can say surface from a plane. I can do a planar curve. So it actually caps that or draws a surface. Okay. Now, I'm going to go ahead and split the surface with this. I'll do a split. The object to split is this one, and then the cutting object is this particular one. So you can now see that this section is being split in here. Okay, you see like a hole or opening right there?
Right.
And you need to basically, you said it has a draft on the floor, right? It goes from a certain angle to the angle right there. Is that correct?
Yes, it's going to go from 1 inch to 1.5 inches.
Okay, 1 inch to, so 1 inch on the left hand and 1.5 inches on the right, or is it the other way around?
Correct. That's correct.
Okay, and basically we need to put a line. So what I can do here is draw a line here. I want to go from this midpoint, and this is where it ends right here.
Correct.
Okay. So I'm going to take this, and then I'll move it down by 1 inch. Okay. All right. And then I need to draw a line that goes 1.5 inches, right?
Correct.
Okay, what I'm going to do is I'm going to move this by 0.5 inch. And then I'll actually, to make it easier, I'll put a line from the point in here to there. So I'm going to just snap to the end point of this right here. So that's the line.
I gotcha.
Right?
Okay.
Now
All right.
You duplicated you duplicated the line at 1 inch, and then you dropped it a half an inch, and then you drew the line between the two.
Gotcha.
Right.
Yep.
So, that was the quick and dirty way to do it, right? So,
Right.
Yeah.
and now I'm going to basically put these on the two sides in here, so that I can then build a surface from those two lines. So now I'm going to go ahead and select them. So that was the, very fast way to do it. So I'm going to basically extend this over here, and I got these. Now I can basically go ahead and connect these endpoints.
Yeah.
And I can use a command in Rhino called create a surface using planar curves. So that puts a plane right there. Okay.
Yep.
Okay.
Right.
Now that we have this plane created, and we have this curve that we have in here, what I can do here is just pick this. I'm not putting in a wall on the side, just keeping it simple. I'm going to do is a 3-axis operation in here and do a roughing. We'll go ahead and pick this as the boundary in here. So the toolpath will stay within the boundary. And because we put a surface on the side, the cutter is not going to go past that. And now you can program this using a 3-axis roughing operation. You can use the same 1/2 inch cutter. You can specify your step down controls, and then you pick generate. So this will automatically create a roughing toolpath in levels, and you can see it automatically knows where the levels are, and I can adjust them and say, so basically it's going to cut it down in levels. Okay.
Okay.
Yeah. You could do that with a flat-ended bit, or did you have to put a ball end on there to smooth it out?
For finishing, you would have to probably go with a ball mill. For roughing, you could do a flattened mill.
Yeah. Okay.
And then I can go from a roughing to a finishing operation. So you have 5 different types of finishing methods that are offered to you in the standard configuration. And I can pick a boundary in here. I can do a finishing by selecting this boundary right here and go from a end mill. I could say I want to go to a 1/4 inch ball mill. I can run it parallel to the y-axis by putting in an angle as 90 degrees, then generate. So that's going to give me a finishing cut. And you can see it follows the surface. Okay.
Yeah.
Okay.
So that's how you'll be able to, program something that has an angle to it. So you got to model it in 3D. And the correct way of modeling is you got to extrude all of this and do it. So I just showed you kind of a quick and dirty way to do it. Okay.
Yep. Yes.
Any other questions?
Yep.
Can I bring a piece of mahogany over there and have him cut that? Huh? Can I bring a piece of mahogany over there and have him cut that for me? Sweet.
Okay.
You know what you can do? Well, I'll show you.
The next operations would be cutting around the profile here. Before we do that, we can probably look at, maybe if you want to do a drill or any of these, it would be a very similar process. And then finally, you'd want to go ahead and do the, what do you call it? the operation to cut the profile on the outside, you can do a 2-axis profiling. And you just go pick the boundary around the part right here. I pick the curve right around the part. You pick a tool, a 1/2 inch cutter. You set your cutting conditions. You want to climb cut, go on the outside. You choose your total depth. It's going to be 3 inches. You can go in steps of like a 1/4 inch. You can specify how you want to enter and exit, and you can also put in an overlap distance in here so the cutter gives you a nice overlap so it doesn't leave any witness marks as you enter and leave the material. And this will give you a profile around the part.
And you say we're going to take 1/4 inch cuts, right?
I'm going down in 1/4 inch steps.
And how fast? Well, that'll depend on our machine.
Depends on the machine and
Right.
the bit.
And the material you're cutting. You can also hold bridges and tabs if you want the stock material to be, if you don't have vacuum holding or you want the stock to be, intact with the material, you can do it. You can see that here, the tool, my flute length is not long enough, and you can see it marks those areas in red, saying that it's cutting deeper than the flute length.
Okay, would we be able to flip that over and cut it from the backside?
Yes, you can. When in our standard configuration,
sure.
you can.
Let me ask your opinion on that. Is it better to get a longer tool? And if you get a longer tool, do you get greater deflection, or flip it over like we're talking about?
Well, if you have features that needs to be cut on the other side as well, then it makes sense to flip it over and machine it.
True. Right.
All right. So you can go halfway down on the first side.
Yeah.
So what I would do then is basically pick this curve that I have, the outline, and I'm going to define it as what is called a predefined machining region. So I'm going to pick this and then define it, and then I can specify where I want the start point to be. So I'll put the start point right over there. Then I can pick locations where I want to put my bridge points. So I'm going to say I want to have the bridge points over here on this area right here, and maybe have a bridge point over here, and possibly somewhere over here. Okay, so I've inserted like 4. I picked the 4 locations for the bridge points, and now
what is a bridge point?
What is a bridge point?
It's going to hold the part intact with the stock, so you're not cutting. If you chose to cut all the way through, then it'll leave like tabs so that the part is being held within the stock, like hold-ons.
Right.
And you can specify the bridge height.
Oh, I got you. Yeah, it'll leave a piece of wood in there so nothing moves within the cut. Yes.
Right. That is correct.
So you see what that is? Like a little bridge.
Right.
Bridge point. That's why I call it a bridge point.
Especially, that would actually be really good if we're cutting top and bottom, because you want to keep it oriented.
Right. Even if you're cutting halfway, it makes sense, because let's say.
Let me say something here first. In order to orient that on your table, on your waste platform, you're gonna have to drill in the stock. You got to drill 4 holes on the outside corners that are equidistant from each other. So when you flip them over, it's the same thing. Right. So your center stays at center.
Right.
Correct.
That is correct. You need to do some registration holes, so when you flip it over, they line up perfectly. That's how when you do two-threaded machining.
And I think if you were thinking about deflection, I think you're probably better off cutting it at, just 1.5 inches.
Shorter tool. Yeah.
Yeah, a 3-inch bit's gonna be more expensive, and you're gonna have more deflection.
You could leave the bridge point right in the middle.
Right.
Of the and then come on later. Right.
As you can see, I put in halfway through right here, and then when I flip it over and machine it, you can use the same bridge points for the other side too.
Yep.
Yeah. Right.
So with the standard configuration, you'll only be able to program it from one side. It means that I need to save this as maybe part top, and then I got to flip the drawing over in the CAD in Rhino, and then save it as bottom. Now, in one of our higher configurations, we have the ability to automatically do multiple setups where we can actually rotate the coordinate system for machining as if you're going to be flipping the part over this way, right? So we can change the rotation. We can say we want to flip 180 on the Y, so we can flip it over. And now we can add a new setup, so you can see the simulation from both the sides as well. And you can put the 0, 0 back to the same corner. And now I can go back and repeat the same profile operation from the other side. And when we generate the path now, cut levels, you want to start at 0, going down to the depth. You can actually see how nicely it shows the simulation from both the sides, and you can see the nice overlapping cuts from both the sides, and you can also see the bridges which holds the part intact.
Very nice.
So this is part of what's called our 3+2 module, which is included in the Pro configuration, being able to do multiple setups, meaning you can program or from multiple orientations without having to create multiple different files. When you output the code to your machine, you would still output each setup to a separate G-code program, because you're going to be flipping the program, the part over on manually on a machine. So this could be setup 1. You could call this for the top, and then this could be setup 2. This could be for the bottom.
Got it.
So the Pro configuration includes these features. The standard does not include multiple setups. Okay.
Right. Yeah.
So is there anything else that you'd like me to go over at the demo today with you?